Hi, so this talk will be on abstract entities, particularly the role of numbers, particularly how they exist in thought, or whether they exist or not, or whether they should be considered in ontology of thought, or etc. This won't be going into dialectical logic, but will be more of an examination of the particular types of analytical thought that exist, within UK philosophy, for example, and imperial philosophy. So typically it splits into two camps. You have Platonists and Nominalists. So Platonists believe that abstract entities actually exist in some sort of a eternal form, or some sort of a realm where ideas are physical and representative in the imagination, whereas Nominalists believe in that only concrete entities are allowed to exist in ontology. So these are obviously like two opposing views of philosophy. So examples of mathematical entities would be numbers, functions, sets. But the nature of such entities, in particular, you wouldn't say it occupies a space, or you wouldn't say it occupies a time. It doesn't have any causal relationship, meaning it doesn't affect anything that happens in the real world of ontology. So without this integral causal relationship, you typically wouldn't say numbers exist. So for example, you would say a bike exists because you can act on the bike as an object. You can objectify it, and for example, if you push the bike, that bike itself would move, so it presents itself as an effect, but also something that could be acted upon at the same time. Because numbers can't exist, or numbers, sets, or functions cannot exist in this kind of integrated relationship with the self, they are deemed not to exist. But even despite this, numbers typically do refer to things. So you can have a group of two sheep, or a pair of two sheep, and then a pair of shoes, a pair of socks, and the commonality between these things would be the number 2. So whereas you may have Platonism that typically allows all abstract entities to exist, you also have a mathematical Platonism that only allows numbers, sets, and functions to exist instead. So there is this key distinction between different types of Platonism itself. So you could allow numbers but not allow other things or other abstract entities that don't meet into this framework. But you could also say, importantly, that if you believe numbers to exist through mathematical Platonism, you are committing yourself to believing that there are abstract entities in some form or another. So you are committed to some form of Platonism, despite that. So for example, if you take the one over many argument, you can have two propositions, for example. So the first proposition being some x is f and some y is f, and x is not y. And then the second proposition will be, therefore, there is a universal fness that x and y instantiate. So typically that would represent there are two shoes, two ships, two cabbages, or two things that, for example, and then the shoes, the ships, and the etc. all have something in common, which is the universal 2. So this manages to commit the individual to 2. Most importantly as well, to understanding what Platonism is, not only it treats abstract entities as real, it treats thoughts itself as having more of a concreteness than material things themselves. So the thoughts on themselves are concrete according to Platonists. So there is a complete reversal of what exists according to their ideology. And these abstract entities that exist in thought do not have any causal relationship, so they can't be forced upon. They can't be changed in any way. So there's no dynamic historical character to objects in this way. They all exist as some sort of a universal kind of character. But what the nominalist ends up falling into is some sort of kind of functionalist or mechanical kind of thinking, because in order to abstract reality, abstract the concrete nature of things and objects as they exist, there needs to be some sort of abstraction to kind of bridge the gap between the subject and object. So in a way, science and numbers in particular that facilitate science, they play a indispensable role. And if you're committed to science and its ability to create observations, great observations, and to a closer examination of the truth, then you're also committed to numbers existing in that kind of way. At least this is the view usually taken by some mathematical Platonists in dispensing with pure nominalism in that kind of way. But as a Marxist personally, there needs to be more of a dialectical relationship between subject and object. So numbers can arise, for example, and give a higher truth to things that concretely exist, and they're necessary. But even though they are necessary, they don't necessarily that we are committed to them in that kind of way. They don't necessarily exist in physical form. They only exist in ideological form, but still a necessary kind of elucidation of scientific reality in that regard. For scientific thought to become intelligible and to become meaningful, it also needs to integrate itself with mathematical language as well. Previously you'd have a scientific early scientific thought, such as alchemy, for example, which was more of a projection rather than compared to chemistry, for example, which is more observational. And you still have hypothesis testing and all that in a scientific thought to a regard, which is like imposing your ideology to basically find specific facts rather than the facts speaking for themselves. There needs to be more of a dialectical relationship between these both. So there needs to be hypothesis testing in some way or another, but it can't be an infinite number of hypotheses. It needs to be a selected number of hypotheses due to the material things and objective criteria arising as meaningful in that sort of way as well. So any scientific formulas do require abstraction in some way or another. They do require formalizations, and they require formulas, numbers, sets, functions, and theories, and all that. So that is absolutely necessary, and it can't be it's indispensable to scientific discovery. In this relationship between mathematics and science, in order for science to be true, mathematics needs to be true. So if you think about it in terms of like a proposition or a logical statement, the antecedent, which is mathematics, if mathematics is true, therefore science is true as the antecedent. So both of these are required to create a true statement, a true proposition. So that's kind of like the logical formation of the maths and sciences interlinked in that kind of way, and both commits you to abstract entities in believing in science and believing in formalizations in the scientific method. So this appears to be a valid argument, but the real question is it really a sound argument as well? For example, if you take a scientific conclusion as true, then that also means that the theory that led up to that conclusion is also simultaneously true as well. But in this also arises as treating the scientific theories and scientific evaluations as universally true, which they are not. They are obviously historically contingent and, operate according to paradigm shifts as well, like Thomas Kuhn says. So while it may be the best theory at the time, it doesn't necessarily mean it's the best of all time. And this usually arises a lot of the empiricist thinking of mainstream philosophy in many ways. It doesn't really, it's not able to understand change properly. It can't integrate dialectics into its thinking. It's too rigid and formalistic. And as a result, it can't understand the temporary nature of numbers and, the temporary usefulness of numbers, that it could eventually be, dispensed away with once you have the scientific theories. And they are you can integrate them into science, but you can also have this kind of like barrier between they don't necessarily have to exist at the same time. They can still be useful, but they don't have to exist. One of the main things of analytic philosophy is to a lot of philosophers like Quine in particular, they wish to use like Occam's razor, for example, which is to not multiply entities beyond necessity. But the thing is, what constitutes necessity? If numbers are indispensable for the achievements of science, then this would count as a necessity in that regard. So the two contrasting arguments are basically, are numbers extravagant in our ontology, or are numbers indispensable? And in many ways, Occam's razor is ultimately trying to force an outcome out of ontology, forcing a limited number of entities to be allowed into concrete reality. So in many ways it ends up with a more mechanical analysis of the world, because it doesn't have this access to possibility. So you could say numbers appeal rationally to an individual. You could say that we should ought to believe in something that that is indispensable, basically, for our best scientific theories. But at the same time, you could also appeal to our relationship to things. So say we're not causally related to numbers, and they are not contingent to history at all, and they can't change in any sort of fashion or form. But either analysis is flawed because it appeals to some sort of projection of what things ought to be. You could instead view mathematics as an incomplete truth or a future truth. So mathematics as it exists on its own doesn't represent anything, but once it becomes applied to something, then the previous thing becomes true. So for example, you could say that the sun, you can make a hypothesis, for example, that the sun will rise tomorrow. And that is not necessarily true until the sun actually does rise tomorrow, and then you can go back to the antecedent and then claim that is true after the fact. So you could either claim that numbers represent a future truth that is yet to be completed, or you could say numbers represent a universal truth, which would be a Platonist view. But overall, this requires more discussion, and I'll talk about it in another video, so thanks.